So let's talk about data visualization. Data visualization is the important part of all the functions. We have been hearing constantly that data is gold. No doubt for that. In the current scenario and in future, the data is going to be the biggest gold. Okay, and data visualization is converting that gold into ornament. Okay. So even if you give any person the gold biscuits or gold brick, that does not make any sense till the time it is actually converted into some ornaments, made be bangles or necklace or any other earrings or anything, or it can be a ring. Okay. So data visualization is basically converting the gold into an ornament. Now the beauty of the gold comes up more clearly when it is able to be able to visualize. Okay. Again, the data visualization is basically the art of saying the story in the form of art of saying the story related to data. Okay. Now data visualization is basically the graphical representation of the information and the data by using the visual elements like charts, the graphs, the maps. Okay, so data visualization tools provide an accessible way to see and understand the trends, outliers, and the pattern in the data. Till the time you are able to see the pattern behind the data, we are not able to make this. Understanding the pattern behind this data or trend behind this data is actually what we call as your making the ornament from the gold. Okay, so in the word of big data analytics, in the world of big data analytics, data visualization tools and technologies are essential for analyzing massive amount of data of information and make data-driven decision. Okay. The first way to represent the data is your what we call as the contingency table. Okay. The contingency table presents the result into two categorical values. Okay, it's important when we understand the the contingency table that this is just an example here that we have got the body image that is about right. Okay, then we have got overweight and underweight. So we have got two genders, that is female and male. Okay, for which the about right female is 560. Okay, and then above overweight is 163 and underweight is 37. Okay, the total of this is coming to 760. Okay. Similarly for male, the total is coming to 440. Okay, always. And then we have got the about right, the total of which is coming as 855, overweight coming as 235, underweight coming as 110. Always remember that in case of contingency table, okay, the sum of the total of the rows and the total of the rows and the total of the column, okay, should be equal. That is one of the criteria of the contingency table. Okay, so depending upon the time of the contingency table created, the cell for each rows and the combination contains the frequency of the percentage of the total overall population and the percentage of total row or the percentage of total column. Okay. So what used to happen earlier that we used to select the chart on the basis of what the way we want to see the data. Okay. So whatever we feel like. Okay. So we can just go ahead and select for pie chart or select for the column chart or select for the bar chart and see the information. Okay. Now, data visualization is important to understand that what we actually want to show, and according to that, select the different chart type. Okay. For example, if we want to go for the comparison of the data, then it can be if you want to show for the among the items, we can go for the category types like column chart or the bar chart, or where we can go for the contingency table within contingency table or table with the embedded chart. Okay, or we can if you want to show across the timeline, okay, then we can go for the cyclic data or if it is circular cyclic data, then we can go for the circular area chart, or we can go for the line chart. If it is for just a few periods, okay, then we can go for the column chart or for the line chart. Okay. Most of the time, if you see the time related issues, we use the line chart. Okay. If you want to show the distribution, we can go for the histogram or we can go for the bell shaped graph. Okay. And if you want to show the variation between two data, we can go for the scattered plot or we can also go for the bubble chart. And then we can go for the three-dimensional area chart. If you want to show the relationship, even if you see we have got two variables here, we are basically trying to show the distribution of the thing. So we also show the relationship. When the relationship is there, if we have got two variables, then we can use the scattered plot. Okay. And if we got three variables, then we use select the bubble chart. Now, in case the bubble chart is basically the extension of your scatter plot where the area of the bubble or the size of the bubble is also impacting. So we have got three variables. Okay. So one variable, say variable one, variable two, giving us on the scatter plot, and then we on the bubble chart. And then on the basis of composition, we can, if it is changing over the time, okay, we can go for the stack 100 stack chart or 100% stack chart, or we can go for the stacked area stack chart, or we can go for 100% area stack bar chart. Okay. Or we can go for the static. If it is static, then we can go for the pie chart or the donut chart. And if it is accumulating or subtraction of the total, we can go for the waterfall chart. And if you want to show the components of that, okay, we can go for the 100 stack column chart or 100% stack chart. So let's understand some of the important charts. Okay, let's understand the bar chart. Okay, bar chart are arranged in the distance between the two bars. Okay, so need to be constant throughout. Okay. And then the height of the bar is basically your scale. Okay, so bar length is basically the value of the amount. When we have got multiple bars, okay, the same thing that we talk about bar is also applicable also on the columns. Okay, so if you are working with the multi-set bar chart, we have got a category or a group. So it can be a fruits, say for example, then we have got banana, pears, apples. Okay, so we have got different category subcategories or products, and then falling under the category. So if we want to show the data like this, we can go for the multi-set bar chart. Okay. Stack bar chart is basically topping one of the other. Okay, it's a extension of the category. In case of multiple set bar chart, what is happening here, that we have got apple, pears, and then we have got banana. When we want to see the category, so basically this particular can be one category. Okay, and this category will be, say for example, we have got banana, pears, apple, and so on. Okay, say for example, we have got oranges. Okay, so it will be one on the top. When we go for 100% stack bar chart, okay, it will be basically all the data will be 100%, and it will be calculated on the percentage of total. Okay, that is the part of the 100% stacked bar chart. So in simple bar chart, we have got one on the top of the other. In case of 100% stack chart, we have got calculate on the percentage. Histogram is basically based on the frequency. Okay, frequency of the population. Uh, then we have got the population pyramid. In case of the population pyramid, the arrangement of this is on the top. Okay. So for example, we have different age group from 0 to 4 to 90 plus. Okay. So we have got males on one side and females on the other side. Okay. So we can arrange it. So basically what is happening here is this is two different bar charts. Okay. So this particular area is considering one bar chart, and this particular area is considering another bar chart. Okay, so the axis it is just opposite to each other, facing just opposite to each other. This is diverging towards the left, and this is diverging towards the right. Okay, now this is way the data is arranged. This is known as the population pyramid. So if we remove this from there, we can put the scale, unified scale. Okay, and put the data in there. Okay, so we have got the zero axis here, and on the basis of zero axis, it is diverging on the two sides. This is the line graph. Okay, line graph is basically, we have also said that it is basically used for showing the time related data. Okay, so it's a basically when the data are continuous in nature. Okay, we use the line graph. Okay. So basically, it is what is happening in the, if you remember when we were using graphs. Okay, so there was the axis. Okay, so we have got one and at the x-axis, two at the y-axis. So we got a point there. Okay, so once we got different points, we connect it with the line. Okay, so in Excel or any other functions, we can have this line as simple line, or we can use the freehand. Okay, in case of freehand, it will be moving a little bit here and there. Okay, but in case of straight lines, it will be basically connecting all the points. This is where what we call as the line graph. Okay. Then we can show the data in the form of timeline. Okay, and the area graph is basically an part where the data, all the data information are there in the lower part of the this particular area. This entire area is divided. So we have got the points similar to what we were having in case of line graph. Okay, and just connect with all the shades and to the bottom of the line towards the x-axis, gives us the area. Okay. Now this area is again, we can have a stacked bar chart. Okay. So stacked area graph, a stacked area graph, we can have the series of data one over the other. Okay. This is the box and the whisker plot. Box and the whisker plot is one of the tool that is used correspondingly in most of the analytical function. Now this is based on the quartile deviations. Okay. So we have got the median. Okay, the median point. Okay, this is known as the box. Okay, and these two sides that is coming out from the box is known as the whiskers. Okay, so we have got the center point of the box. The box is again divided into two parts. Okay, the center point is that you will see the cross marks in many of the cases here. That cross marks actually represent the median. Then we have the lower quartile. Lower quartile, this one is lower quartile. Okay, and this is the upper quartile. Then we have the lower extreme and we have the upper extreme. In many cases, what happens, say for example, when we are working with the data related to compensation, okay, the salary of the CEO is far ahead the average salary of, in most of the cases, far ahead the salary of the average or median position in case of the employees other than CEO. So what happens that when we put that into box and the whisker plot, we find that the salary of the CEO is coming here. Now, when it is coming outside the whiskers or the upper extreme, then we call this as outlier. Okay. Then again, the same condition can happen with the some peons. Okay, who serve the tea or anything. The salary is quite less. Okay, so it can be below the lower extreme. Now this is also an outlier. Now next here is the pie chart. Okay, pie chart is basically converting that entire into percentage. Okay, so we start with converting into the total of the percentage, and then we calculate on the 360-degree. Okay, so we once the percentage is there, then the total circle. Okay, we start with from here till here. It is 360-degree. Okay. So this 360-degree, the percentage of 360-degree of each of the category will be representing that data. Pie chart is going out of fashion slowly. Okay, and it has been replaced by the donut chart. Okay. The difference between donut chart and the pie chart is that the center space here, okay, is not occupied in case of donut chart. Now this is open. Okay. That is the thing, and then again the donut chart is also used for making the progressive charts. That is not possible in case of your pie charts. Then we have the sunburst chart. Okay, Sunburst chart, we have got the central node. Okay, so for example, we have got the organization here. Under the organization, we say may have the two departments. So we have the accounts department, and then we have the sales department. Under the sales department, we have got the marketing support, then we have got service marketing, and then we have got, say, product marketing. In the accounts department, we have got related to banking, and then we have got non-banking related accounts. Okay. So that is where it is arranged on a hierarchy. Okay, so we have got organization, then under organization we have got two department, and under two department we have got three sub departments. So that is what we call as the sunburst. Okay. Tree diagram is more similar to what we do in case of sunburst. Okay. Then we have got the tree map. Okay, in case of tree map, what happens is that we have got the entire data is set on the basis of the area of that. Okay, so we have got say for example, we have got the pet shop. Under that pet shop we have got birds, mammals, fish and reptiles. So it will start from the left hand top and then go on to the right bottom, the size of the pet shop. Say for example, we have got birds, that is the maximum number of birds that is there in the pet shop. So it will be starting from there. Okay, in birds we have got zebra finches, that is occupying the maximum number. So it will start from here and so on. It will keep on moving. The size of the box will be representing on the total this area that is occupied by in the tree map is that what is information is available on the number or the size of the category or the product we are talking about. Then this is a scattered plot. Scattered plot is basically arranging the data. So it's on the X and the Y axis. Okay. So we have got different point. Now scattered plot is also used to identify the outliers. Okay. So if we draw a straight line here, okay, and we see any data that is far away from the scattered plot. Okay. Now this is basically what we call as the outlier. Okay. Now this scattered plot can be negatively arranged, positively arranged, linear, exponential, U-shaped. Okay. Then we have the proportional area chart. Okay, the proportional area chart is the chart is completing the area. Okay, and then area will be on the square root of the length of the will be the square root of the area. Then there is a bubble chart. The bubble chart is the size that we got the position. Say for example, this is an x-axis or one variable. This is two second variable, that is y. Okay, so we have got the scatter plot arranged. Now we each of the size of the is showing the size of the variable, another variable called say z. Okay, so we have got another variable called z, and that is so we have got three variables here. Okay, the size of this bubble will be basically representing the area, the amount or the quantity of that particular variable. Then we have the waterfall chart. Waterfall chart is basically, or most of the time, it is used for the financial related data. Okay. So we have got some investment, and then we have got some. So it is keep on adding the whatever the investment is coming, and then we have got some expenses that is coming, and then finally we come up with all the expenses, and then the residual we left with this amount. Okay, so this is basically showing the flow of the data. Another way of showing the data is map labeling with the field data. Okay. So we have got some informations or say some data related to different states in US, and this is basically converting it into different areas. Okay. Now this is the mixture of two things. One is that we have got this area that is replacing, and we have got this as labels. Okay, another important thing is that the color is increasing from when the data are less, the color is light, and then when it is darker, it is going on the darker side. Now this is basically getting on the heat map. Okay, so heat map is basically increasing the heat and then increasing the color. The reverse of the pyramid chart is your funnel chart. The funnel chart is basically the data that is coming here. The data that is coming here. Okay, so all the data. So in case of what happened in case of your population pyramid, that the number of population was just on higher on the lower side. Okay. But in case of your funnel chart, the population will be on the maximum on the upper side and then arranged. Okay, just reverse to the your population pyramid. So this is basics of data visualization, basic tools. You just need to remember all this thing while working with the data visualization.